In today's presentation, we are going to cover Chapter 2.4, Find Multiples and Factors, within the Prealgebra textbook from OpenStax. Now, the core objectives that we will take a look at in this presentation include identify multiples of numbers, use common divisibility tests, find all the factors of a number, and also identify prime and composite numbers. So let's go ahead and get started. Okay, let's first answer the question, what is a multiple? So a multiple of a number is the product of that number and a counting number. So if I define counting numbers are 1, 2, 3, 4, 5, 6, so on and so forth. So if I want to figure out the multiples of 2, we're going to take our number 2 and we're going to multiply by each of these counting numbers. So 2 times 1 is equal to 2. 2 times 2 is equal to 4. 2 times 3 is equal to 6. 2 times 4 is equal to 8, and so on and so forth. So 2, 4, 6, and 8 are all multiples of 2. Now, multiples are the numbers we get when we skip count. So again, for example, with multiples of 2, if I skip count by 2's, we have 2, 4, 6, 8, 10, so on and so forth. Or if I get 3, we have 3, 6, 9. I'm skip counting by 3 here. 12, 15, so on and so forth. Or 5, 10, 15, 20, so on and so forth. So I'm skip counting by each of these multiples here. Now, how do we actually find multiples? So these are some steps that you could potentially use to find multiples. So first, you can start with whatever number you have. Then you multiply it by your counting numbers, and you list the products at the end. So for example, if I say, what are the multiples of 4? Again, the same process would be, you can start with the number itself, 4, and then you multiply it by those counting numbers. So 4 times 1, 4 times 2, 4 times 3. Again, I'm just increasing the counting number by 1. 4 times 4, 4 times 5. Now, if I've figured out what the products are, so list my products, we have 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, 4 times 5 is 20. So these are your multiples of 4, which you could then list out them as multiples. So in this case, if you're listing out in answer form, you would have 4, 8, 12, 16, and 20 as the initial multiples of 4 that are, in this case, less than 20. Now, some ways to actually define multiples of 2. Multiples of 2 are even numbers. For example, 2, 4, 6, 8, 10, 12, 14, and 16. So a number is a multiple of 2 if the last digit, so it's a multiple of 2 if the last digit is even. In other words, the last digit can be 0, 2, 4, 6, or 8. If a number has the last digit of these, then it is even. So if I give you an example, let's say you have 3,714, and I asked, is this a multiple of 2? We would look at the last digit here, and we recognize that, that last digit is 4. 4 is even. So we can say, okay, 3,714 will be a multiple of 2. Very long in the distance, a long part of the list if you were to list them all out, but we know that is a multiple. Multiples of 5 then always end in 5 or 0, right? So if any number, so for example, you have the number 50 or you have the number 75, or you have the number 5,555, so all the fives. Anything that ends in 5 and 0 will be a multiple of the number 5. Likewise, multiples of 10 will end in 0. So for example, we have the numbers 10, 20, 30, 40, so on and so forth. Each of these end with the number 0, so they are a multiple of 10. A larger example of this would be 350. I don't even necessarily need to test this in my calculator since I see that 350 ends in 0 here. We know that this is a multiple of 10. In fact, if I was to break it up into what are called factors, which we'll soon learn about, 35 times 10 is equal to 350. Again, the multiple 10 multiplied by the number 35. A little bit trickier to test is a multiple of 3. So to check if a number is a multiple of 3, there is a test you can do. A little bit trickier than obviously knowing if something's a multiple of 2 or whatnot. But what we can do here is we can add the digits of a number, so sum them. And then if that answer, if that sum is a multiple of 3, then the original number is a multiple of 3. So this works really nicely if you have a bigger number. So for example, let's say we have 645. This is a lot more difficult to see whether it's a multiple of 3 just by looking at it, but the shortcut, I guess, or a test you can do is you can add the digits 6, 4, and 5 together. So you could do 6 plus 4 plus 5. And when you do 6 plus 4 plus 5, you get to 15. Now 15 is much easier to determine, is this a multiple of 3? So 15 is in fact a multiple of 3, right? 3, 6, 9, 12, 15. 3 times 5 is 15. So because 15 is a multiple of 3, this also makes, due to this test, 645 a multiple of 3. So let's do a question. You can pause the video at this point to test this. So is 489 a multiple of 3 here? All right, so to test this out, what we can first do is we can add or sum each of the digits. So we can do 4 plus 8 plus 9. So 4 plus 8 plus 9 is equal to 21, right? 4 plus 8 is 12. 12 plus 9 is 21. Well, 21, that's much easier to see if that's a multiple of 3. In other words, you're basically asking, can you do 21 divided by 3? And 21 divided by 3 is equal to 7. Well, if I go the other way, 7 times 3 equals 21, right? So since 3 is a multiple of 21, this also makes 3 a multiple of 489. Now, one of the questions you'll be asked on the quiz this week, or from the textbook chapter I'm reading, is to list all the multiples of 6 that are less than 50. So in this case, what you can do, again, you could list all of them out if you want to. This is one strategy. So if I go less than 50, we could start with the number 6, and then you're just increasing by counting numbers. So this is basically what you would see on a times table, right? So 6 times 1 is 6. 6 times 2 is equal to 12. 6 times 3 is equal to 18. So these are multiplication facts that you could spend a little time memorizing, or use your tool, your multiplication times table, to help you out initially. 6 times 4 is 24. 6 times 5 is 30. 6 times 6 is 36. 6 times 7 is 42. 6 times 8 is 48. And then 6 times 9 is 54. Now this is obviously too big because it says to list all the multiples of 6 less than 50. So we are stopping right here. So if we were to actually choose an answer choice, the answer choices that we're choosing for this will be the products. These products of each of these facts are the multiples then of the number 6 here. So what does divisible mean? So if a number is divisible by another number, it divides evenly into it. So this means there is no remainder to that number. So for example, if I have the number 375 and I divided that by 5, you could test this in your calculator if you'd like, what you will end up getting is 75. Now there is no remainder, nothing left over, so we know that 5 goes into 375. We could also say 375 is a multiple of 5. Now, why this is important is because multiples and then divisibility work hand in hand. If a number is a multiple of another number, then it is divisible by that number. So as I kind of just noted in those statement previously, if I actually type this out, so we would say 375 is a multiple of 5. Now, what this means then, so 375 is divisible by 5. We could basically write two different facts from this. We could say again, 375 divided by 5 equals 75. Or I could go the other way and say 5 times 75 is equal to 375. Okay, so multiples and divisibility work hand in hand here. Now, there are divisibility tests. I brought up a few of them already that allow us to know if a number is divisible by another number. So again, like multiples, if the digit ends in 0, 2, 4, 6, or 8, it's divisible by 2. If the sum of the digits is divisible by 3, then that particular number is divisible by 3, right? We tested that earlier. If the last digit is 5 or 0, then it's divisible by 5. One that we haven't tested, I'm going to spend a couple questions on now, is the number 6. So if a number is divisible by both 2 and 3, meaning it passed both those tests, it's divisible by 6. And then if the last digit is 0, it is divisible by 10. So let's go ahead and ask the question, is the number 78 divisible by 6? So again, if I look at my testing chart, a number is divisible by 6 if it is also both divisible by 2 and 3. So let's first off then test. So the number 2 test. Does 78 pass the number 2 test? So if the digit is 0, 2, 4, 6, or 8, if it's even, it's also divisible by 2. Well, 78 ends in 8, so we would say yes, 78 is divisible by 2. What about number 3? A little bit trickier. So what we're going to do here is we're going to add 7 and 8 together. So 7 and 8 together gives me 15. I then can ask, is 15 divisible by the number 3? Well, yes, right? 3, 6, 9, 12, 15. 3 goes into 15, so we would also say yes, it's divisible by 3. So with those two tests in mind, I then go to number 6. Is 78 divisible by 6? And since it's divisible by 2 and it's also divisible by 3, then the number 78 is also divisible by 6 here. Okay, so we would say yes. So you'll come across some numbers where it's divisible by 2 but not 3, so that means it's not divisible by 6, or vice versa. It might be divisible by 3, like the number 9, for example. Number 9 is divisible by 3, but it's not divisible by 2, so 6 doesn't go into 9 either, right? So that's kind of the thought process we're working on for each of these. All right, now let's try another number. Let's do 750. So is 750 divisible by 2, 3, 5, 6, and 10? So let's test that. So first off, the number 2 here. Is 750 divisible by 2? Well, if I look at the rule, if the last digit is 0, 2, 4, 6, or 8, it's divisible by 2. 750 ends in 0, so that means yes, it's divisible by 2. What about the number 3? So if I take 750 and I add all the digits, so this is summing all the digits, we get 7 plus 5 plus 0. This equals 12. Does 3 go into 12? It does, right? 3, 6, 9, 12. So because of that, it's also divisible by 3. That's kind of cool. What about the number 5? Well, 750 ends in 0, right? And if the last digit is 5 or 0, it's divisible by 5. So we would also say yes, divisible by 5. What about the number 6? Well, remember the number 6, we have to pass both this number 2 rule and the number 3 rule. Since we already did that, yes and yes, we would also say yes for the number 6. And then does 10 go into 750? Well, because it ends in 0 again, we would also say yes, 750 is divisible by 10. So that's kind of interesting. In this case, it passes all the rules here. What is a factor? So a factor is a number that is multiplied by another number to get a product. So for example, I can have the multiplication fact 8 times 9 equals 72. This means we would call the number 8 a factor and the number 9 a factor. And then the number 72 is the answer. This is also known as the product here. Okay, so 8 and 9 are factors of 72. Now, factors are connected to multiplication. If two numbers multiply to make another number, then those two numbers are factors of that number again. So another example of this, 4 times 6 equals 24, and 2 times 12 also equals 24. We can say that 2, 4, 6, and 12 are all factors of the number 24. Now, because factors are connected to multiplication, it also means factors are connected to division. So if a number is a factor, or excuse me, a number is a factor if it divides evenly into another number. So for example, if I had 24, that was the product in the previous slide, divided by one of the factors 6, and it equals 4, because there is no remainder, this means that 6 and 4 are both factors of the number 24. Now, factors come in factor pairs. So to define a factor pair is a pair of numbers that multiply together to make another number. So for example, if I was to list out the factor pairs of the number 24, we have 1 times 24, 2 times 12, 3 times 8, and 4 times 6. These all equal the number 24. So we would say the factors of 24, if I was to put them in a list, we usually list them from smallest factor to the biggest one. We would say 1, 2, 3, 4, 6, 8, 12, and 24. Now what's interesting again, since these are factors, these are also all divisible by 24. If I was to do 24 divided by 2, I get an even response. 24 divided by 8, I would get an even response, number 3, for example. So how would we find all the factors of 36? So these are some of the steps that are listed in our textbook this week. To find all the factors of the number, we can first start by dividing the number by counting numbers in order. If the answer is a counting number with no remainder, you found a factor pair. And then you can stop when the answers become smaller than the numbers you are dividing by. This is one strategy to solve this problem. So for example, we'll take the number 36, and I'm first going to start by doing 36 divided by 1, which is the number 36. Now what's interesting, 1 is always going to be a factor of every number. Then we go to the next factor, 36 divided by 2. This is also an even number, so we would get the number 18. 36 divided by 3, we would also get another even number. You get the number 12. Now, one tool you can use when you're first starting to do this is you can use your multiplication times table. Some of these you might also use long division to help you solve these. But for now, I just want to get an understanding of the definition of factors and factor pairs here. Okay, so 36 divided by 3 is 12. 36 divided by 4 is equal to 9. 36 divided by 5, this is going to be something that is not a whole number. If you were to put this in your calculator, what you get is 7.2 as a decimal. So in other words, you would get 7 and you would get a remainder. So 7 remainder something. It's technically 7 remainder 1. You have 1 remainder, okay? So this is not a factor pair. And then we have 36 divided by 6, which equals 6. Now, at this point in time, because our factor that we're dividing by gives us an answer that's either equal or smaller than that number, we can stop. So stop when the answer becomes smaller than the number you are dividing by. Well, that has now been the case. So at this point, we can now list all of our factor pairs. So our factor pairs are basically then what we divided by and then what we got equal to. So 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6 are going to be your factors. So if I then go and list the factors here, we have 1, 2, 3, 4, 6, kind of go back up the wheel now, 9, 12, 18, and 36. Okay, so this is our factor list for the number 36 now. The final objective that we have for today's presentation is to identify the difference between prime numbers and composite numbers. So let's first answer the question, what is a prime number? So a prime number is a counting number greater than 1 that has exactly 2 factors, 1 and itself. So for example, 1 times 7, which equals 7, is the only 2 factors that 7 has. So because 7 only has 1 times 7, 7 is considered to be prime. Now, the other category of number when we talk about prime numbers is what's called a composite number. Now, a composite number is a counting number with more than 2 factors. More than 2 factors. So for example, if I have the number 12 here, and I looked at all the factors of 12 include 1 times 12, which equals 12. It includes 2 times 6, which is equal to 12. And it includes 3 times 4, which is equal to 12. So the factors of 12 are 1, 2, 3, 4, 6, and 12. In other words, it has a total of 6 factors, actually, 6 total factors. So that doesn't meet the definition of a prime number. A prime number has exactly 2 factors, 1 and the number itself. Now, what about the number 1? So the number 1 is special. It is not prime because a prime number has two factors, it's also not composite because it has only one factor. So because one has only one factor itself, it's its own unique number. It's not categorized within either of those groups. Okay. Again, prime numbers have exactly two factors. Now, if I listed out some more prime numbers, the following are prime numbers that are most often used when we do something called prime factorization, which we will look at in the next presentation, which is in chapter 2.5 in the textbook. So let's go ahead and look at what are the prime numbers of 20. So prime numbers of 20 include 2, because 2 times 1 is the only factors of 2. We have 3, again, only 3 times 1. Now if I look at 4, 4 is not a prime number because you could do 1 times 4 and you can do 2 times 2, right? So that isn't, these aren't, this is a composite number, in other words. Other prime numbers less than 20 include 5. I'll just list them out now. 5, 7, 11, 13, 17, and 19. Okay, so these, when I kind of look at doing prime factorization, 2, 3, 5, 7, 11, 13, 17, and 19 will be the most commonly used prime numbers when we do prime factorization by hand, at least. Now, another unique prime number is the number 2. So 2 is the only even prime number. Why? Well, the factors of 2 are 1 and 2, meaning that it has exactly those two factors. And then all other numbers that end in an even number, a 0, a 2, a 4, a 6, and 8, means that it's divisible by 2. So by definition, any even number is composite unless it's just the number 2 here. Now let's go ahead and look at some questions and we're determining whether a number is prime. So there's a systematic way of thinking about this, noted kind of in the textbook here. So let's ask the question, determine if 77 is prime or composite. And what we can do here is we can test each of the prime numbers in order to see if it is a factor of those numbers. So again, if I think about prime numbers in order, and I was to list out my prime numbers, let's go ahead and put that up here. So this is nice to always have kind of a listing here. We have 2, 3, 5, 7, 11, 13, 17, and 19. Those are the prime numbers less than 20. So we can start with the smallest of them, 2, and then stop when the quotient is smaller than the divisor or when a prime factor is found, right? Okay, so if I look at 77, 77, is it divisible by 2? Well, it's not, right? So it's not divisible by 2. If I was to put into my calculator, I would actually get 38.5. So it's not a remainder here, so we know it's not a prime number. 77 divided by 3. Okay. So 77 divided by 3, also not divisible here. You could do the test if you wanted to, where if you added 7 plus 7 to get to 14, 14 is not divisible by 3, or if you actually put this in your calculator, you get something like 25.6. So that's not a prime number. If I did 77 divided by the next prime number, which is 5, 77 does not end in 5, so it's also not divisible by 5. If you put this in your calculator and did 7 divided by 5, you get 15.4 here. The next prime number, 77 divided by 7. So 77 divided by 7 is actually indeed divisible, so it's 11. So what does this tell you? What this tells you is that 77, since 77 divided by 7 is equal to 11, we know that 77 has more than two factors, right? You have 1 times 77, and then you also have 7 times 11. So 77 is considered to be a composite number here, right? So basically what step 3 says, if the number has a prime factor, then it is a composite number. If it has no prime factors, then the number is in fact prime. Trying another number, we have the number 83. So we know 83 is not divisible by 2, right? Since it doesn't end in 0, or end in 2, I should say, or an even number. So 83, if I do each of these divisibility tests, not divisible by 2. If I did 3, well, let's test it. If I did 8 plus 3, so this is the divisibility test for 3. If I do 8 plus 3, we get to 11. And I ask myself, is 11 divisible by 3? And it's not. Right? So put an X. Divisible by 5? Well, to be divisible by 5, it has to end in 5 or 0. It's not, so we could X it out. 7, there's not a great divisibility test for the number 7, so you could try 83 divided by 7 kind of either in your calculator or by hand. And what you end up getting, though, is a 11 remainder 6 here, or a decimal. So this is also not prime, right? Next prime number is 11. Oops, that's a lot bigger than expected. Okay, 11. But if I do 83 divided by 11, what you end up getting is 7 remainder 6. Now I want to stop here. Notice how the next prime number I did was 83 divided by 11, and my answer is 7 remainder 6. So 7 is smaller than 11. So the quotient, meaning the answer, is now smaller than the number we divided by. It's called the divisor. So since the quotient, the answer, is smaller than the divisor, we can now stop checking for prime numbers, and we can basically determine and state, okay, 83 is in fact a prime number. Okay, so those are the differences between prime and composite numbers here. So in this presentation, to summarize, the outcomes we covered were to identify multiples of numbers. So again, multiples of numbers include taking a number itself and then multiplying it by a counting number. So for example, 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6. So in other words, 2, 4, and 6 are multiples of 2. We then also looked at common divisibility tests. That was in that chart. So for example, if I look at the number 3 is a unique test. If you take a number and you add those different digits together, and if the sum of those digits then were divisible by 3, then we know that the bigger number is divisible by 3. Okay, so there's some unique divisibility tests that you can keep with you. So keep those in your notes. Then we looked at how to find all the factors of a number, so the factor pairs. And then we looked at identifying prime and composite numbers. So go ahead and get into the textbook now and do a few of those practice problems. If you have any questions, do let me know. I would be happy to create follow-up videos for you. Thanks everyone, and good luck.